Hey, folks, we're going to give people a little time to join here. We'll start the meeting at about 4 minutes after the hour here. Hi, folks. Like I said, we're going to start about 4 minutes after the hour, give some people some time to join. We are live here for the event. And as we're letting people enter the meeting, we'll get started shortly. We'll give it just about 1 more minute here to let people to join. All right, folks. I have 4 minutes after, so let's go ahead and get started here. Good morning, good afternoon, or good evening, depending on what part of the world you're joining us from today. Welcome to our session, Unlocking the Potential of Data in Retail. Today, we'll explore how data transforms retail and brand strategies. We'll introduce you to a modern approach to data architecture, and we'll demonstrate these concepts in action. I'm John Esmile, and I'm delighted to be your host today. We are also fortunate to have with us Tom Robertson. Tom is a seasoned expert in data analytics, and he will share a wealth of knowledge with us. Let me briefly introduce our company, Confiz. We are a systems integrator helping businesses globally to leverage the power of digital transformation. Through our collaboration with leading cloud vendors such as Microsoft and Google, and data platforms like Microsoft Fabric, Databricks, Snowflake, and BigQuery will guide you in new possibilities. Let's go ahead and dive into how data can be a game changer for your business. One thing that I do know, as you go through a digital transformation, the effort to do that must deliver an ROI. So increasing revenue, bringing products or services to market faster, boosting profitability, and all along enhancing customer satisfaction. And all these are not theoretical. It is reality that we have witnessed, which we have been a part of over our years of working in the retail and brand space. Companies that embrace data-driven strategies can significantly outperform their competitors and achieve remarkable growth. Solid analytics is a strategic advantage in retail, from optimizing stock levels to personalizing customer interactions. It's all about making informed decisions that increase profit and enhance customer engagement. For instance, understanding the latest trends in fashions or changes in weather patterns can help you align your inventory with your customers' needs, ensuring the right products are available at the right time in the right locations. Consider the power of precise sales forecasting. With our AI ML engine, businesses can predict market demands with incredible accuracy to facilitate smarter decision making. This technology enables companies to anticipate changes and adapt strategies, ensuring that they remain competitive and responsive to market trends. A modern data platform is essential for any business aiming to leverage data effectively. It's a comprehensive system that integrates various technologies, process, and design to handle data at scale in an efficient manner. By adopting such a platform, businesses can unlock valuable insights, drive innovation, and achieve sustainable growth. With that, I will pass the ball off to Tom Robertson, and he will take us into a modern data platform using a lakehouse first approach. Have at it, Tom.
Thanks, John. Welcome, everybody. So let's dive into the lakehouse approach here. Let's start talking about frameworks. So some key components and benefits of a modern data platform. We begin building this platform on some supporting foundational capabilities that are critical for these solutions. Scalable, flexible, cloud-native products and services and infrastructure as code, data governance and security that's unified and shared across the platform, metadata management and data cataloging capabilities across the platform, and overall, the platforms encourage collaboration and provide for integrated workflows. So to begin with, we want to have a platform and an architecture that supports batch and streaming data in the ingestion of data from any source, data of any type. We need somewhere to store that data, somewhere that's inexpensive, resilient, highly available. And we want to store it on cloud data storage that accommodates all data types, again, structured or unstructured. We need a place to actually integrate that data, bring it together, and curate it to create a single source of truth, remove errors, provide data where data may be missing, and enhance it and augment it with other values that we join from other data sources. Then we want to move that data into a transformation aggregation layer, a gold layer, if you will, that provides a highly performant layer for BI and analytics. And then overall, our platform is going to support an architecture framework that provides for machine learning and AI that can use this same data all in one platform. So let's talk about a lakehouse for just a minute. Lakehouse architecture was developed as an open source framework that combines the benefits of data warehouses and data lakes. I pulled out a definition just for a common definition of a data lakehouse. Modern data architecture creates a single platform by combining the key benefits of data lakes and data warehouses. And lakehouses enable organizations to use low-cost storage to store large amounts of raw data while providing structure and data management functions. This definition is from Google Cloud Platform, and you'll find many definitions out on the web, and they're all similar. So let's talk about some of these key features of lakehouse architecture. The first one we're going to talk about is open storage formats. So this is the format used to store files within the lake. These are open source formats, and they're available to all. There's no proprietary vendor lock-in. You don't need a license from any specific vendor to access the files and read the content. You don't need special tools to access the data. And I'll give you a couple examples of those formats that are familiar to you. One will be Parquet format, CSV, comma separated value text files, XML files, and JSON files. Let's talk about decoupled compute and storage layers. This is a key feature of lakehouse architecture where the different layers of compute and storage have been decoupled, allowing for optimization within their own environments so that they can be independently optimized based on workloads. This is a key feature. Another key feature is transactional support, which provides similar capabilities to a data warehouse or online OLTP system. So transactions are all or nothing, they're consistent, they're isolated, and they're durable so that we can rely on the fact that they're there even if the system fails. We have a schema enforcement and evolution. The schema defines the column names and the data types for the data contained within, and it provides for data integrity and rejects writes to the table that don't meet the schema rules. These schemas can be evolved over time, and they provide the flexibility to modify the table schemas, add columns, change data types to accommodate new data elements or changes to existing ones without recreating tables and reloading data. Lakehouse architecture supports a wide variety of data types and workloads. Structured data, examples include relational databases, perhaps your ERP. Unstructured data, such as photos, audio, and raw text without column headers. Batch and streaming data that we ingest from devices, perhaps in retail, footfall information that comes from sensors within stores. Analytics, machine learning, and AI workloads are also supported, all in a unified solution framework that eliminates the need for separate platforms and duplication of data based on workloads. Lakehouse architecture provides metadata governance and security across the environment. The metadata layer handles the metadata for the Lakehouse data and supports schema tracking, lineage, versioning, and enables querying of past data states, and it enables features such as time travel. Governance. This layer manages the trusted data with a unified catalog detailing objects and metadata, enables data discovery and lineage tracking, so you can understand the journey of data from ingestion to landing to transformation. Where did the data come from? How is it combined? And what does this value tell me? Security. And this layer controls, obviously, and controls and audits data access and ensures that the data is secure and monitored across all assets. Here we have a diagram that gives you the Lakehouse architecture framework. And you can see across the left-hand side that we have different sources of data. So streaming data, I mentioned footfall data, structured data, for instance, maybe your ERP data, semi-structured data, which would be text files, CSV files, and logs, and unstructured data, which you can think of as, for examples, PDFs and images. So this solution supports real-time streaming through a stream ingestion engine that lands data in a data layer. It also supports batch and change data capture for all data types within this realm. In the middle here, you'll see bronze, silver, and gold cylinders. This is a medallion architecture framework for data, which basically encompasses the raw data landing in the bronze layer, which it hasn't been changed. We don't do anything to the raw data. It's in its pure form as we found it when we ingested it. The silver layer can be thought of as the filtered, cleaned, and augmented data layer, where we've ensured the accuracy of the data, we've removed invalid data, and we've corrected errors within the data, and perhaps enhanced it by adding different values to the data. The gold layer is the layer where this is used for SQL endpoints, used in enterprise and BI reporting, and data science and AI and ML. This works across all hybrid cloud support, so cloud providers like Azure, AWS, and Google. So it provides for an integrated, flexible data platform for managing all types of data sources. And of course, once we have our data within one environment, shared across the platform, it reduces the need for data duplication and enables the same use of data across different workloads, such as BI and data science. So let's look at a couple of providers for Lakehouse solutions. The first one we have here is Databricks. They're a well-known Lakehouse provider, and you can see the different personas that they offer within their tool: data warehousing, data engineering, data streaming, and data science. And you can see the Unity catalog here that provides fine-grained governance across the data, across the platform, and Delta Lake, which is an open source format for maintaining tables within a data lake, and provides all the features that I reviewed for the Lakehouse architecture. Another provider is Microsoft Fabric. You can see a similarity here in the personas that are based on workloads that different people perform within the industry, and the different shared security, shared lake storage, universal compute, so similar functions across that. And here we have Copilot AI assistants. Databricks also has their own AI integration as well. All right, so why do we want to do this, and what can we do with these systems? We have all these data sources, as you see across the left-hand window here. Perhaps we have cloud data warehouses, on-premise systems. We have SaaS applications that we're using in retail. We're getting application logs, perhaps from the applications that specialize in our sales or help us manage our stores. And we're getting mobile and IoT data, again, that footfall or sensor data that we have coming in from our stores or locations. We need to integrate this data efficiently across many different platforms, and we need to bring it in from streaming buses. So we may have cloud storage in Amazon, it could be in Google Cloud or Azure. We need to bring all this together to unlock the value of the data. So that why do we want to do that? So that we can use BI tools with it. So to access the data to gain insights. So using tools such as Tableau and Power BI to obtain data for use in ML and AI solutions so that we can do predictive analytics, do predictive maintenance, personalize offers, perhaps do patient diagnostics, and to rely on data to automate action through prescriptive analytics, to do alerts, fraud detection, and dynamic pricing, perhaps. So the purpose of this webinar is really to talk about machine learning, and we're going to do some demos on machine learning experiments. And the role of the data engineer in ML and AI is to help with the data scientists as they do their problem formulation, figure out what data exists, doing data discovery so they are aware of all the available data and its characteristics, the selection of the relevant data sets for the experiment, the best data that we can use to start with. And then we help with the data pre-processing and feature engineering, which is the process of transforming the data into meaningful features to enhance the performance of ML models. We'll show some features later on and how we do this engineering within the ML example. We select, create, and modify these data features to extract relevant information and reduce noise and improve the predictive power of the model. Once we've curated the data, now we have experiment-ready data. It's cleansed, it's augmented to ensure common schemas, data types, and formats. We've removed all the null values and corrected incorrect values. So this is clean data and it's ready for use. Now, we have an accelerator at Confiz that we've built that helps you extract and ingest the data from different platforms. So API data over here on the left, you can see structured data. Again, an example, maybe your ERP system, unstructured data. So think of these as text files. And cloud data. Perhaps you have data stored out in ADLS in Azure or S3 in Amazon or GCS, Google Cloud. We built a series of Synapse data engineering notebooks, Spark notebooks that use a Delta table within a lakehouse, a series of Delta tables that store metadata and configuration information and logging information that the notebooks use to dynamically ingest data from these sources. It also performs orchestration by triggering other notebooks that can be used to pull the data from the raw layer up here into the Spark notebook, process it, curate it, perhaps correct some issues with the data, and then store it in our silver layer. Furthermore, we can trigger other notebooks if we want to design a dimensional model for use in Power BI or other analytics tools, and we would load that into the gold layer. And down here, you can see an example of Synapse Data Science, a tool using the silver or the gold layer to access data so that we can do some data science experiments with it. This could be any data science tool. It does not have to be Synapse Data Science. This is an example. So now we're going to get into our demonstration. And what we're going to demonstrate first is data extraction and curation using Data Factory pipelines. And then we're going to do it with Spark Notebook as well. And then we're going to actually run a machine learning notebook, again, a Spark notebook. And we're going to do a sales forecasting machine learning experiment. We're going to run through a series of 3 experiments. We're going to grade the experiments and evaluate them and see which experiment we think produces the best model. And then I'm going to show you how that experiment's stored within Fabric and then can be turned into a machine learning model on demand when we've basically determined that there's been enough training on that model. So this process flow is going to look like this at a high level. We're going to have a data warehouse example. In this case, it's a SQL Server database that's in Azure. We're going to connect to it with a data factory pipeline from Fabric. And we're going to pull that data into the raw lakehouse. We're also going to demonstrate connecting to a data set within file storage, a container in Azure, through a shortcut, which means the data isn't actually in Fabric, but linked to Fabric. This could be done with Azure, it could be done with AWS, GCP, and other providers. And we're going to process that data with a Spark notebook. We're going to move the data through the raw layer into the silver layer to curate it. And then we're going to conduct ML experiments and train a model on that data. And then in the end, we're going to have a series of experiments that we've conducted that anyone could be selected to create a model that could be used in the future to enhance data or processes on demand. With that, let me get into the demo environment and I will share my screen. Let's begin with an example in Microsoft Fabric of how we can ingest data. Let's start with a data factory example. This is the launch page that you see when you start in Microsoft Fabric, and here you can see the different personas that are available in the platform. From Power BI, Data Factory on through Synapse Real-Time Analytics. We are going to focus on Data Factory in this example. So I'm going to click to the tab where I've already started a Data Factory persona. You can see down here at the bottom, I have my different personas based on what I've selected. So I'm in Data Factory and I'm going to choose to create a new data pipeline for the purposes of our example. And this is going to be a SQL DB demo. We're going to ingest some data from Azure SQL DB. So I'm just going to click this, create a new pipeline. Fabric's going to spin up a new pipeline here, and I'm going to click Add Pipeline Activity so we can kind of walk through these steps. And I want to copy data out of a SQL database. So you can see here I have my design screen, and what I'm going to do to begin with is I'm going to set a source where I want to go get this data from. Initially, you can see that it came up. It wants to direct me to a workspace and would allow me to choose from a lake house. And if I selected that, I could choose bronze layer, gold, or the various lake houses that are available to me in this environment. For this example, I want to go get an external data set. I want to go look for that SQL database that I want to pull a table in from to demo how we can target a table for this example. Our partners on the database team have informed us that there is a useful file out here in a pre-existing database that has store information and demographic information that we think might be interesting in a machine learning experiment. So we're going to go after that table. I have some various databases here. I am going to pick the one that is an AdventureWorks database. This is an Azure SQL database. So this is where I'm going to get my sample data from. I'm going to test that connection and ensure that it works. You can see there that our connection came back successful. And I want to pick a table, and I know a specific table I want. I want the sales schema, and I want the store table from within that schema. I've been told there's some useful demographic information for the stores itself that we might be able to use in our experiment that we can integrate with other existing data. So let me just take a look at that data real quick if I want. I have a preview button here. And you can see as it brings up the preview of the data that there actually is some useful store survey demographics information in here. And we can use that within our experiment. So we're going to go ahead and select this data. We like the way that it looks. So we're going to set a destination. In this case, I want to bring it into my workspace. So I'm going to select my workspace. I want to store it in a lakehouse, so I'm going to leave that lakehouse. And this is raw data that I'm bringing in from SQL, but it's also data that's structured. So we're just going to choose our lakehouse bronze location. And at this point, I have an option of loading this data into a table, a Delta table, or I can load it into a file. In this case, I want to demonstrate the ability to pull in a file. So I am going to use a file ingestion example. I'm going to put this in a directory named ingest SQL demo, and I am going to put this into a file named store info. Now you can see here I can also select how I want to store this data, what format, and I'm going to choose Parquet. All right, then I'm going to save this pipeline. And then just really quickly after that save's complete, I want to come over here to the lakehouse, the bronze lakehouse, and I'm going to take a look at that folder that I have for under files for the ingest SQL demo, and I'm going to do a quick refresh on it. We're not going to see any data here because I haven't run the pipeline yet. Then I'm going to go back to my interface here on my pipeline. and I'm simply going to click run to run this pipeline. Now I could run this based on an event. I could also run it on a based on some trigger or timing per se, any type of condition that I want to execute it on. I'm just running it manually. And you can see here I've clicked over to the output screen. This work has been queued, spinning up, beginning to connect to the database, look for that table. And it'll keep refreshing as it goes. There we go. We can see that that pipeline activity succeeded. It has executed successfully. We get a notification up here, and we should be able to go over and look at our ingest SQL demo folder, do a quick refresh, and we should find that, yes, indeed, we have a file over here named store info. This is how you can quickly and easily connect to a SQL database or any database really on-premise or in the cloud and select targeted data by using a pipeline. Now, of course, this was a simple example. We could have created a for loop to loop through all the tables within the database or selected multiple tables. We could have executed further notebooks or transitions after we ingested the data, but this is a simple demonstration of how to ingest data using Microsoft Fabric Data Factory pipelines. Now I'd like to demonstrate the capability in Microsoft Fabric to attach to external storage in Azure or any cloud provider and work with that data without initially moving it into the Fabric environment, just accessing that data remotely. I'm going to integrate that data, curate it, transform it, clean it up a little bit, and demonstrate how to explore it. For this demonstration, I'm going to use the Synapse data engineering persona, and I'm going to use a Spark notebook. So starting that persona, the interface that comes up, we'll see that I already have some notebooks created. So I'm going to work right now today in our sales order raw to transform data demonstration. So I opened that notebook, and in the essence of saving time, I already had that notebook up and open. So we can see here when we look at the screen, we have resources on the left, which is our Lakehouse Bronze. It has tables and files. And in this case, for this notebook, I'm going to be working with this data sources shortcut. And you can see this is a shortcut actually by the link that's associated with the file folder. And then within this link folder, I have another subfolder named orders. And you can see that there are 3 CSV files within this folder. If I quickly move over to my Azure environment, I can show you that this is data that's sitting in my Azure environment for this demonstration in a container and blob storage, and you can see the 3 CSV files. So moving back to the notebook, I'm going to go ahead and start the notebook and let it run, and then I'm going to talk through it. So we're going to basically click here, run all, and we're going to start executing the notebook. And this notebook's going to demonstrate going out to that Azure Data Lake storage, grabbing those files in a CSV format, bringing them into a data frame so that I can kind of explore that data. So the first thing I'm going to do is read the data from the location in the link. And you can see here I've specified a single file, the 2019 file. And I've read it, and I just chose to display 5 rows here so that I can see some of the data that's coming in. You can see some interesting things already in that we did specify a header, thinking there might be some column definitions here, and we can see that there are not. So we're going to have to define this data as well. So to do that, we come down here and we've got a block of code where we're going to define a schema with the correct column names and data types for the data frame. So basically, we're going to create the schema, we're going to apply it to the data frame, and then I'm displaying that data frame to demonstrate that the column names have been applied to the data. And you can see that here. Moving down, we saw at the beginning, we have 3 files here that we need to bring together into the data lake or into the data frame to work with so that we can integrate that data, begin exploring it. So what I'm going to do is I'm going to read that data. I'm going to look at all the files that are within that link location. that are all CSV files, and I'm going to combine them into one data frame. And you can see that that's been done here. Now that I have that data all aggregated into a single data frame, I can begin working with it as a group. Now, just really quickly, I want to validate that I actually brought that data in. I'm going to do a quick, group by here by the year and account on the orders column within the data frame. And we can see that I have data from 2019, 2020, 2021 with a count of the data. So we can see that we've integrated our data into our data frame. The next step to prepare for machine learning is to begin to explore the data. So Spark Notebooks give you a really flexible way to look at data in many ways. We're just going to kind of do an example here where we're selecting distinct customers and we're looking at their email addresses, just demonstrating that you can work with a subset of data within the data frame to explore it, see what type of data you have, and begin profiling it. Here I'm profiling the data and filtering it basically to see what customers perhaps purchased a specific product. In this case, it's a specific road bike. And we can see here the customers that made that purchase and their email addresses. Moving on down, we want to work with the data, get it ready for machine learning. Oftentimes we need to transform data. We need to split columns out or take date columns and create columns that have a year, a month, or a day. And in this case, this is what we're doing. We're taking the data frame, and you can see in the code here, we're defining we have a function that we're using called with column that's going to split out the order date for us by month and year. We're not so interested in the date. You can see here below, after we've gone through this, the output. I'm also going to split the customer name. The first and last name was provided in a single column called customer name, and I'm going to define two new columns, last name and first name, and I'm going to split that data out. You can see here below, after my commands executed, I displayed this data frame, and here we can see that I have the order date, but I also have the additional column of year that I defined and the month, the number month. I also have the first name and the last name columns as I define them from the customer name that combine them both. So now I have these separated and I can work with these in an orderly fashion. Now that I've gone through the data and I've kind of cleaned it up a little bit, split out the year, the month, the first names the way I want, and this is certainly a simple transformation and curation. There are many things that we could do to this data to prepare it for machine learning. So these examples are done. Now we want to save the data that we have. So we're going to put it into a file within our lakehouse, and you can see here I've executed a command that's going to store it in a Parquet format and put that data within our lakehouse in the bronze layer. Then I'm going to read that data from that file, that Parquet file, just to validate that my data came across and I actually stored it as expected. And we can see the data being read from the Parquet file, and we can see that it came back in the correct format, first name, last name, split with my year and month columns. I have a Parquet file now in my bronze layer, and I'll show you that in a second. But I'd also like to actually save this data in a Delta format as well, so that I have a Delta table that gives me certain capabilities that could be beneficial in the future. So transactional capabilities, it's going to store metadata, give me historical data, and allow me to do time travel across this data to see how it changes over time. So I'm going to execute this cell, and I'm going to store that Delta table. And you can see here, I'm going to store it in my Silver Lakehouse, and I'm going to store it as curated sales orders. So just real quickly, I'm going to look in the transform data under data sources and orders, and I'm going to do a quick refresh of the files that we have there. And we can see that I have stored these Parquet files within the Bronze Lakehouse under the orders folder. These were created from the notebook that I just ran. And if we move over here to our Silver Lakehouse, we can also do a refresh on our tables, and we should see a new table pop up. That's our curated sales orders table. And I can click on that and get a quick sample of data from that as well. That'll show the data in the new format. So this is an example of ingesting data from a remote data source using a shortcut within Fabric to bring that data in the Spark notebook into a data frame, explore it, curate it, transform it, persist it, store it within the lakehouse in a Parquet file, and then furthermore in a Delta table. Okay, let's do a demo of sales forecasting using Fabric and the Synapse Data Science persona. So we'll go into Synapse Data Science, and I've done a little filtering here to select just notebooks and experiments. You'll see I have a sales forecasting for store items notebook, and I've opened that. Here we see a depiction of the data flow. So pulling some useful data out of our data warehouse, in this case, the fact table that has store sales data in it that's aggregated. We're going to do some work with that. We're going to attach to that lakehouse through a shortcut, as you can see the link here. And we're going to use a Spark notebook to pull some of that data into the notebook, do some work with that data, curate it, conduct some ML experiments, and train a model, potential model, and then we're going to have that experiment that we can create models with. So within this notebook, I'm going to go ahead and kick this notebook off and let it run while we're all looking at things. The first step is to install the libraries that we need to do the work with, and that's what this section is. Then we're going to load data, the sales data from the silver layer into a data frame so we can start doing some work with it. And that you can see that running here. Great. Now we have data in our data frame, and you can see some rows here kind of depicting just the head of the data. And this is going to enable us to begin doing some exploratory data analysis. This is a really important step, critical step in data science and machine learning. And this is where we're going to start profiling the data, looking at what we have, understanding the values within the data set and what we're working with. And here you can see a little bit of that beginning to take place. So we're going to check the description of the data frame, and we're going to get a profile of the data. So we're going to get a count on how many dates we have in here. We're going to get a mean of the date and the different values, a min, 25% bucketing, 50%, 75, and the max values, the standard deviations as well. So just kind of some basic data profiling going on here right now to help us understand what the data looks like. We're going to check the shape of the data frame, which is simply the number of rows and columns of the data frame so that we understand what we have. And we can see here we have slightly less than a million rows, and we have 4 columns that we're really interested in within this data frame. And those 4 columns, we've got the data types here. So we've got the date, which is obviously date time. We've got the store, item, and sales. So now we know the columns and the data types. We're going to check for unique values within the date column. Again, just a little bit of profiling of the data. These are examples. So we can tell that we have 720 distinct dates in this data frame, so we understand the span of the data. We're going to check for the unique number of stores represented within the data too. And we can see here from this command that we have 10 stores that are representative in this fact table. And then we're going to get an idea of the unique values within this data frame. For the item column, we can see we have 50 unique items within the data set. Then we're going to do a little cleanup here and see, what state is our data in? Can we check for null values? Do we have empty, missing data that's going to be a problem for us? So we run the command. We can tell it's really clean, actually. We don't really have null values. So we're pretty good to go. So at this point, we have clean data, and we can get started creating a model. We're going to group the data together, in this case, by date and the sales. We're not really interested in the item of the store. We're really interested in the day of the week, total sales, month, year. So we're going to plot all this data out, store sales over a period of time to see what it looks like. And this is the ability within a notebook to build a graph. We're using a library to build this, this linear graph here so that we can see what our sales look like over time, over years. So this gives us an idea of what the data actually looks like. Then an important part of preparing for a model and training a model is to split the data into training and testing data sets. This will allow us to evaluate how well our model is doing. The training data set is obviously what it sounds like. That's the data set we use to build the model. And the test data set is what we're going to use to evaluate how well the model is actually performing on its predictions. And we can do some graphics on this as well. And we can see the training set and the test data set divided here. Now we're going to do a little bit more viewing of the data. We're going to see what data looks like over a week, days of the week there, over the dates. We're going to view that data over a monthly period so we can kind of see the peaks and valleys and get a feel for what this data actually is within our data set. And then we're going to start feature engineering. And this is the process of selecting which columns or data elements we want to use in our model and what's meaningful to us. And in this case, you can see that we're going to be doing features based on the day of the week, quarter, the month, the day of the year, day of month, and the week of year. So let's visualize the relationships between the feature and target variables here and kind of see what we've got when we start to look at things within the data. Here you'll see we have a box plot. So we're box plotting sales on the week that gives us a distribution, high and low ranges, and where our median values fall, and then where the outlier data may be. These box plots are very useful for determining the shape of our data. We can do that by month as well, and we can start to see trends here, or actually, how our data is distributed over time and what the quality of it is, and whether or not we've really got a lot of variance or outliers within it. We don't have too many outliers. We can see this within this depiction. And we can do the same thing on quarter. Now that we've kind of plotted out the data and we understand it, we can get down to creating a model. So now we're going to select and train using different algorithms on a labeled data set and see if we can learn patterns and make predictions on the new data. So here we define our training set and our test set, and we've defined our features, and our target variable is sales. We want to understand what happens to sales based on these features. So we're going to experiment and test using these different models. And the first one we're going to start with is a linear regression model experiment, and we define that. And then we're going to execute that, and we're going to view the predictions based on the linear regression model experiment. And here we can see the true data represented in blue lines. You can see it spiking through here. And you can see where the linear regression model has made its predictions and get a kind of idea of the quality of the prediction. Then we're going to do some statistics on it. We're going to understand what the root mean square deviation, the MAE, and the R2 score is, so we can kind of evaluate the accuracy, or which model is the best for our which model works best for our experiment. We're going to try a random forest model, and then we're going to view the predictions from that. We can see they're more scattered. And then we're actually going to try an XBoost model experiment as well. We're going to run that. And then we're going to get into determining, which of these features are the most important to us. What is really making a difference within this experiment? And here we can see the year, right? So, basically sales over a year varying. This may or may not be as useful to us as the day of the year or the day of the week. Then we're going to try to test some predictions and view the results in comparison to the actual data. So here's a test of true predictions in raw data. And we're going to do that over our different models. Then we're going to compare the results. So after we've run the different models using our different regression tests, we're going to get the results from those, and we can see those mapped out here in a graph. Linear regression, random forest, and XBoost. Random forest is coming out as our best model. Right? Lower numbers are better, so we can kind of clearly see that on our graph. So we're going to use the random forest model as our best prediction. And we can see here a depiction of the data, what it looks like as it goes through. So this is just a display of, now that I've done my predictions with the different models, what those values look like. We're going to do a little error calculation on that. We're going to group by those, understand what that error rate is. And now we're going to move into trying to predict some future sales. And here we can see a depiction of the true data, the prediction data, and then the forecast data and how that's coming out. We can do sales forecasting for a month. We can do it over a period of 1 month. We can see the different values for the predictions. We can do it for a year, and we kind of map out that prediction. You can see the dots. They're a little bit hard to see, but you can see the dots here, 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 here. So this is what the 1 year prediction data looks like in a tabular format. So at this point, we could continue training the model, or we can choose to store the data. Since this is a demonstration, we're just going to store the forecasting data in a lakehouse in a delta table. So we're going to convert this pandas data frame into a PySpark data frame. And then we're going to save the delta table in the gold layer so that we actually have this data saved. So at this point, we can move over to our experiments, and I can refresh this, and we can see that we have our models that we've run. We can see that we have feature dates and importance. And actually, let me rerun this or refresh this screen so that we have the latest experiments loaded. There we go. And these names are randomly assigned. I did not come up with these names. So Silly Jelly is the name of the model that, or the experiment that Fabric came up with. And we can see here day, year, day, a week, feature importance. Day of the year is really coming out to be the most important feature within these models. All right, so now we have experiments. We can actually take these experiments, and you can see here that I can save this as a model if I want at this point. And I've got some stats on that on this experiment run, or I can continue to experiment until these numbers get to where I like them, and then I can create a model. And then let me show the end result where we stored the data in a delta table. You can see here within my gold lakehouse, I have a table called sales forecasting, and it has my sales forecasting data with the prediction data written. This is a demonstration of sales forecasting using Synapse Data Science in Microsoft Fabric.
All right. Thank you, Tom. We are opening up the chat now for questions. And Tom, if you can, or Mayor, share the screen with the Q&A and the QR codes, it would be appreciated. So the chat session now is open for questions. If anyone has any, they can put them in the chat frame. It always takes people a few minutes to think of a question. All right. While you're thinking through your questions, if you have any, we do have a couple ebooks that you can download and dig into these topics a little bit deeper, as well as our organization will provide a complimentary modern data state maturity assessment. In that work that we'll do for you, we'll invest some time from our side to sit down, talk with you, understand where you're at today from the data maturity level, and we can help draw out a roadmap into a modern data platform that you can leverage the current technology that's available from our leading cloud vendors. All right. Any other any takers for questions? As at the auction house. Going once? Going twice? All right, we sold you here for the event. Oh, wait, we got one unknown user typing. Let's see if we have a question here. If not, then we'll depart on our way here today. All right, it was a complimentary saying they liked it, so everybody grab the QR codes. We'll follow up with emails as well. And we appreciate your time today. And hopefully we'll be talking to you in the near future of how we could help you with a modern data platform. Thank you, everybody. Have a great day.